All right. So welcome to Tempo Community Call, whatever month and year it is, 2022, February, I believe. We got a bunch of stuff to talk about today, including we have a group from Pyroscope, which is awesome. We're interested to hear about some continuous profiling details, as well as I think they're working on some kind of trace to profile linking. And I think I'm personally really excited to see what they're working on and to get an idea of what that looks like. But before we get started there, we have we're going to talk about our latest Tempo release this past month. We're going to get into search, some more serverless discussion, how we're using serverless at Grafana. And then we're going to just talk about metrics generator again, where we are in that. We're making progress there as well. So with the releases, I think Zach is going to take a look at that. Oh, we have a presentation. Somebody put a presentation together, didn't they? Was it Mario?
Nice. Yeah, I like to see presentations. So yeah, on the release front, I just checked the doc. It looks like we did cover the 130 release last time, so I won't belabor that here. Do check the release notes. There are a few breaking changes that are worth pointing out. So yeah, take a look at that. We did have a 131 release since, which is a simple bug fix in the case where you're using etcd as the key value store. That will that caused a panic. So 131 will fix that. You'll want to upgrade if you are using etcd. And that's all we have for the releases right now.
Cool. I was kind of surprised anyone was using etcd. We only use Gossip here, and then our other backends use console. And I didn't think anybody really used the etcd ring mechanism, but apparently someone does. Mario, bud, you kicked out the person who's trying to join.
Yeah, I think I rejected someone. I was typing and.
All right. Well, hopefully they'll try again. We certainly want anyone to be able to come.
I will pick them in Slack.
Okay. Cool. Cool. Mario, do you want to present? You have the last piece, so if you just go ahead and present, then I can talk through my slides and you can do your part as well.
Should I go now? Sorry.
Oh, I was going to say, if you present slides, I'll talk through them. So we don't have to flop a bunch.
Will do.
This is the super professional and well produced Tempo community call.
We could have some intro music or something, and then we'd be pro.
We should have intro music.
That can be arranged.
If you can do it, please do. Zach, that's your new job.
Is that the correct one?
Yeah, that's what Zach was talking about 131. We released it a week or two back. And then, right. Did we talk about the breaking changes? Zach, did you detail some of those?
Yeah, we did cover it in the previous meeting. I was just checking the notes, but we can talk about that a little bit if you want.
Mention them, yeah.
Yeah, there are 3 breaking changes in the 130 release. One of them is the OTel gRPC receiver default port changed. So you'll want to make note of that, firewall rules, policies, etc. It looks like also they were doing this to get out of the ephemeral range of the port list and into something that is actually codified by IANA. So if you look in recent versions of your Etsy services, you will see open telemetry listed there. Super exciting for them. Also, config change. There's 2 parameters that moved from the query config to the query front end config. So you will want to make those updates if you are using search max result limit or search default result limit. Both of those will end up on the query front end now. And then also we removed a deprecated gRPC endpoint on the ingester and its associated data encoding. This was deprecated back in 1.0. So if you're running earlier versions, you need to upgrade to 1.0 first and allow that to blocks to be rewritten as the new encoding. So just that's the 3 there, and then we got a whole pile of features. So I would highly recommend checking out the release notes for the remaining features.
Cool, thanks. In particular, 130 included backend search for the first time. We're going to talk a little bit about that now, kind of what we have going on for like this full scan of our GCS or S3 or whatever object storage. We've already had some people experimenting with the tool, which is cool. I think that really points towards how excited everyone is to be able to search their full backend with Tempo instead of using logs or exemplars to jump into traces. But there's going to be some hiccups here, and there's going to be some config we have to talk about. And so let's talk about what we're doing in search, what we're doing at Grafana, and hopefully we can help you all. Get your search configured correctly. So go ahead, Mario, if you want to move forward. So that serverless help, I think Mario copied what was in our doc. But if you look in the community call doc, that's a link to our docs in our just our standard Tempo documentation, and it talks about some of what we're going to cover today, or real quick here, some of these config options that you might need and help you get started with serverless and getting your backend search to work with serverless, which is what we're using at Grafana. Also, oh, that is totally wrong. It's not Grafana 386. I'm sure I typed that wrong. It is Grafana 836. Nope, sorry, Mario, you got it. That was you, bud. Grafana 836, which was just released yesterday, supports backend search. We need to update our docs. I think we say a future Grafana version, but we'll update it to say 836. And you need to include, and I'll include this here, there's a feature flag, backend tempo search. So we're still marking this as beta. And the reason we're marking this as beta is because it's just not at the performance we want it to be for our level of ingest, which is about 250 megasecond. I think once we reach that scale, we'll feel comfortable dropping that tag and saying it's GA. We also just want it to be a little easier to configure. It's still a little bit gorpy in that world, and I'll show you some of that and talk about why it's a little rough. Right, serverless help. And then we also added Lambda support since 1.3.1 was cut. This was like last week. I built a code package for Lambda, and so if from the Tempo repo, we have a simple make command that will make a Google Cloud Functions package, which you can use for your serverless functions there, as well as a Lambda package, which you can use for AWS Lambda. So we're experimenting both of those. We run in AWS, Azure, and in Google Cloud, and so we'll eventually get all three of those cloud providers. Yeah, let's go ahead and move forward. So this is kind of the architecture and the way we're searching, or we're making use of serverless. So currently, when you do a trace by ID search, the query front end hits the queryers, and the queryers both ask the ingesters, and then they search the GCS bucket directly. With serverless, if you want to use serverless for search, we, instead of digging directly into the GCS bucket, we query a serverless endpoint, and it's just an endpoint that you configure using this query search external endpoints. So if you want to use serverless, you have to configure this value, which will tell the querier not to do the search on its own, but instead to kind of offload the work. So with this configuration point, your querier is basically a proxy when you're doing these range searches, when you're doing these like time range searches with different criteria, like you're looking for different tags or durations or whatever. So the query front end builds up a whole bunch of jobs. It scans the bucket. It knows how many blocks that need to be searched. It makes a bunch of jobs, which it then creates a giant queue of these jobs. The queryers take the jobs one at a time. Some of the jobs say, go look in the ingesters, and some of the jobs say, go query a certain time range in the backend. If you don't have this external endpoint configured that search the backend, the query will do it itself. You don't need serverless. So the queryers are set up to completely search the backend on their own. But at certain scales, and if you want certain like latencies, then you basically have to have some kind of burst capacity, which we're using serverless technologies to do. So these jobs that say go scan the backend hit the querier. If that search external endpoint is configured, it will just hit the endpoint. It becomes a proxy for the query. And then you're kind of offloading this into a serverless technology like Lambda or Google Cloud Functions. So that's kind of like the key config option that turns on serverless. It changes your querier from attempting to do the work itself to offloading it to something in the background. Cool. Why don't we go ahead? And to give you some numbers about what we're really trying to hit before we drop this beta flag. So we're doing 250 megasecond of ingest. Because we use replication factor 3, that actually turns into 750 megasecond written into GCS. We attempt to compact that away, but that's kind of like the search space at time 0, essentially. It's 3 times what we're ingesting because of our replication factor. And then over time, that kind of gets reduced as we compact some of that away, but still, it is kind of makes a challenge for recent searches. We have 202 query front ends, and for a single hour, if you make a request for a time range of a single hour, regardless of your conditions, it creates about 38,000 jobs. So 38,000 small jobs for the queryers to do that are like scan this small range of a block. And they all kind of take these jobs, and either the queryers are doing those or kind of the serverless function is doing those. We have 50 queryers, and these queryers kind of act as proxies for the time range search. For the trace by ID search, they still do the work, but for the time range search, for the backend search, they become this proxy. And we're seeing spikes to about 2,000 serverless functions when we're doing this search. So, it starts at 0, of course. To have that, you see a graph down there of count of active serverless functions in GCS or in GCP. And so the querier, is sitting at 0, of course. And then you start asking questions. You start doing these time range searches. The query front end hits the queries. The query starts slamming the Google Cloud functions, which then scales up very rapidly, and you're able to service your query hopefully pretty quickly. And this is kind of the current bottleneck we're hitting, which is GCS is really only allowing us 5,000 to 8,000 or so queries per second. And that's what we're really trying to move past right now. And it kind of generally, we want to be agnostic about our backends and just kind of think about them as generic object storage. We don't care. We're writing blocks to them. We're querying back. It doesn't matter. But to really push the limits of these backends, we find that we are going to have to get into some of the details. So I've been off this for the past couple days, but I think next week I'm going to get back into this very seriously, which is kind of how do we get more throughput out of GCS, and how do we push it harder? Because our entire infrastructure for search is capable of doing this 250 megasecond search. Everything is set up. We just get bottlenecked on GCS. GCS will just start throttling our queries. It starts returning 429s and other error codes indicating it just won't handle any more requests. So we need to figure out how to move past that. And that's kind of where we are, I suppose, on search. And I expect there to be S3 issues and Azure Blob Storage issues, and we'll kind of move through all those and kind of gain knowledge as a community as we build out all this technologies or all this serverless technology. Cool. I think I have one more slide, 2 more slides? Question mark? Yeah, okay. This one's kind of a super boring slide, but it shows you some of the config points that you're going to have to look at if you start dealing with these huge jobs. So if you're doing 100, 200 megabytes a second, you're going to have tens of thousands of jobs. You're going to need to make some of these changes. They're documented in that link in Tempo community call, so don't feel like you have to just digest this all right now. Go look at that link. Every line I have in here is also in our public documentation. But I'm including some timeouts. So our read and write timeouts are up quite a bit, of course, because these become more like batch jobs, which is not the feel we want, but it's just the way it is right now. So we have our HTTP timeout set at 2 minutes on the query front end. And then we have to massively increase the number of jobs will perform by the query front end. So you'll see there's this max outstanding per tenant where I think it's only like 50 right on trace by ID search or 100, but we're going to like 10,000 basically, 100,000 because we make 38,000 jobs and we have to put all of those into queues. So we have to increase that quite a bit. And there's some other queue kind of configuration options there. And then the querier also, by default, will only try a few queries at a time. And we need to up that massively as well because the query becomes this proxy and no longer is doing the work. So instead of the default, which I think is only like 2 or 5, which was a default setup for query by or trace by ID search, you have to massively increase that value as well. So max concurrent queries, I think on ours are like 1,000. Each of our queriers will handle 1,000 queries at once, but handle 1,000 queries means proxy these to serverless basically. So these config points are what you have to kind of hit inside of Tempo to unlock Tempo and unlock all the bottlenecks inside of Tempo, at which point the bottlenecks become your backend, I suppose. But we're kind of trying to figure that out right now. And then finally, I have just a quick blurb there. We support GCP and AWS, and it's a simple make command. This just makes a zip file. You can upload that zip file to a GCS bucket or an S3 bucket, and then you can build your serverless function in Terraform or however you do that. And you can reference this code package, and it'll work. Cool. Maybe one more slide for me, or was I done?
No, that's it.
That's it for me. Okay. So serverless, we're very excited about, but we're kind of just learning it as we go. We feel like for these extremely, these extreme environments, extreme high load environments, it's going to take a little bit more nuance. It's going to take maybe a little bit more data structures on the back end to get the speeds that we want. But it is functional and available now, and we use it internally. We're also rolling this out to cloud. In cloud, our volumes are, our per tenant volumes are at a level where we feel comfortable rolling this out. So all of our cloud customers are going to have access to this, to their full backend search. And we're going to be iterating on this in the next months, years, frankly, to improve performance, add features, kind of build this query language we're going to start talking about, and other things. Cool. So search is in a good spot. If anyone has any questions, you're welcome to ask now for serverless. There's been quite a few questions in Slack and in the GitHub issues about how to set this up and other concerns people have. If you have questions, you're welcome to ask, or we can save that for the end. You can ask in the chat, or you can unmute if that's your style.
That was very cool, Joe. I have one question.
Yeah.
How did we get past the cold start problem in serverless? I saw that like in the number of jobs, the graph that you showed us, it was like at 0, and then it would like massively scale up to like a couple of thousand. How did we get past like that cold start?
Honestly, cold start really hasn't been an issue with GCP Cloud Functions. I've kind of had my eye on it, but the bigger bottleneck right now is the GCS requests. Another field I set was, and I think I referenced this in the docs that are linked in the Tempo community call, but there is in Google Cloud Functions, there's like this min instances you can set. So it'll always keep one alive. And I did see that making a substantial difference in cold start. Just telling it to keep a single one around seemed to be meaningful over 0, basically. Something else I noticed was if I do a code update and I push a new package and then I update my function, the very first query after that update often took a long time. Like there was a serious cold start issue there versus, even if I waited like a day, the second query on that same, function was significantly less. So that very first query seemed to have the worst cold start issues. After that, it did okay. So certainly with serverless functions, I think you're always going to be trading off, right, some kind of cold start latency in exchange for, this huge kind of extreme burst capability. And I think that's just always going to be like a challenge when we use this. But I think that's okay. Like the amount of data we're scanning, the kinds of things we're trying to do, I still think this is the right choice. And there just might be this like min latency of 1 to 2 seconds on cold start queries. And I think we're going to have to be okay with that.
Yeah. I think if it's happening just one for every new function, that's pretty okay. Not too bad.
Yeah. The worst one is that one. We should set up a job that just like curls it as soon as we roll it out or something.
Vulture.
Right. The instant we roll out a new version, just curl it so we hit it and the customer doesn't. I don't know. It's a good idea. Cool. All right, I'll hand this over to Mario. We've been doing a lot of work on metrics generator. We've been talking a lot about this in the community calls. And I think we have some updates in that world as well.
Yep, that's right. So metrics generator, server-side metrics, we kind of use them interchangeably. And well, the first update is that our design proposal has been accepted. We opened a design proposal for this project about a month ago. Right. And yeah, I mean, we gathered some feedback. I think we were happy at the point we were at. I think, yeah, we have a good base to build a solution. So yeah, it's been recently accepted. And it will be merged soon. So yeah, we encourage everyone to take a look at it. Even if we're accepting it and merging it, please feel free to ping us at the Slack if you want to chat about it, comment on the design proposal, open an issue, open appear against the design proposal. It's not definitive and written in stone. Yeah, we will be iterating the project and making changes as we build it. So yeah, we appreciate all the feedback that we can get. So yeah, well, the next slide is maybe you should have come first. Is so what is actually the metrics generator for those who don't know? Just to refresh everyone's memory. So the metrics generator is a new component that we have designed to solve this project. And this new component is used to derive metrics from ingested traces. So it sits at the right path and it will receive all the traces that the ingester receives. So the distributor will now write to the ingester and to the metrics generator. This new component will derive metrics from traces and will be remote writing them to a Prometheus backend. Initially, we have designed two kind of metrics that we're deriving. One, which is what we call span metrics, which are basic metrics from spans. Essentially, every span is a goal, and yeah, we're trying to extract as much relevant data from spans as possible. And the other one is service graphs, which is this feature that we built for the Grafana agent, in which we inspect traces and try to match spans as requests from the client and server perspectives. With that, we can build metrics that represent how services communicate, and we're able to display like a complete graph of a distributed system in Grafana based from those metrics. Yeah, I mean, this was the quick introduction to the project. But if you want to discuss dive more into technical details or have any question, feel free to ask. We're happy to go into them. And finally, well, almost finally, what are the next steps? At the same time, we've been working on the design proposal. We've been building an initial implementation based on that design. And yeah, we're opening a pull request with this initial implementation. We also encourage everyone to take a look and give any feedback. It's always appreciated. And as for when this will be released, we're targeting Tempo's 1.4 release. So I will say a couple of months. It's a fair estimate. And yeah, also to announce that as well as on this being on open source Tempo, we'll be integrating it to Grafana Cloud Traces. So this will happen automatically when using Grafana Cloud, which is very cool. And now, truly, finally, we have a quick demo to show kind of what metrics we're generating right now with this initial implementation. And yeah, see all the cool stuff that we have.
Yeah, I'll quickly share my screen. So I can do a quick demo about the metrics generator and how we are running it right now. So we have the metrics generator deployed in a development cluster internally. And it's currently, just generating metrics all the time. And we're using this as a platform to try out our new code and see how it works. So just to give everyone kind of an idea of what these metrics look like, I can just show them and go to different graphs you can get from them. So this is our internal tenant that contains all the metrics on the metrics generator. And you can see if you open a metrics browser, the metrics that we generate. So currently we only have 2 processors, or we already have 2 processors, depending on how you want to see it. So we have the service graphs processor, which generates the metrics backing the service graphs, as Mario explained. And we also have the span metrics. These can also be generated by the agent, but in this case, we're now generating them by Tempo itself. So Tempo is ingesting traces and also generating these metrics at the same time. And just to give like a quick example of what you can do with them, the span metrics are great to see like historical data about your spans. So we are generating these metrics, these aggregated view, high-level view of all these little traces, all these requests that happened. And you can see stuff like the rate of the request, the duration, the amount of errors. So like the typical red metrics. So to give an example, this is a histogram quantile of the P95 of the span metrics. I trimmed it down. I only show the spans that start with HTTP GET Tempo API. So that way I only show spans, that are part of the Tempo API in this case. And then you can see them here. So in yellow, that's the trace ID request. So all the requests to fetch a trace. And in green, those are the search requests. And then you can see like, what kind of pattern is there? Is it slowing down? Is it slower than usual? Like that kind of stuff. What's also really cool is, we're generating metrics from traces. So we have this full trace information at the moment that we generate the metrics. So it's very easy to inject exemplars into that. And so all these green little dots you can see, those are exemplars that we added to the metrics about the traces that these metrics are based upon. And so what you can do is, for instance, see, oh, there was a slow request here. That's kind of weird. You can see the labels of these requests. And then you can jump to Tempo to query this trace. And then you can immediately see like, oh, why was this request slow? Maybe it was hanging somewhere, whatever. You can continue exploring. And what will be really cool is something we will try to implement in Grafana, is that if you're able to go from a span back to span metrics, so that you can go in the opposite direction, that you can select a span and you might wonder like, oh, what do the metrics of this span look like? And you can generate like a new graph here with the latency of this specific span. And that way you can go back and forth and like, just explore your traces, explore your requests, and hopefully find, something interesting. So those are the span metrics. And the other set of metrics we're generating are the service graphs. And so the service graphs, these metrics extract information about how your services are linked together and how the requests, how many requests there are between each service and the latency between those. So what you can see here is, for instance, we are collecting traces from Loki. And this is like how the Loki components are talking to each other. So there's a gateway, a distributor, ingester, and you can see the arrows of how the requests are flowing through the system. And you can also zoom in and then see like how many requests this node is receiving every second, and also kind of the latency and stuff like that. This isn't the final UI because it's a slightly older version of Grafana. But in the new version, there's also the option to see a histogram and to jump to the histogram like in a separate panel. So you have the full graph view there. This UI is constantly improving as well.
I think you can actually jump to some data in this one. It's just on the nodes. Yeah.
Oh, yeah. Okay. Yeah.
Yeah. The query is not the best. But
oh, yeah. Make like a read query from it.
All this is improved in, as Conrad was saying, in new versions of Grafana.
Yeah, this is an example of what the service graphs look like. So you always have a client and a server, and then like the amount of requests that happened or the latency of those requests. And every client server pair is what we call an edge. It's like a jump from one service to another. But yeah, this is currently being worked on Grafana. So yeah, expect to see some improvements all the time, basically. Yeah, and that's kind of what I had to show for like the metrics.
Nice.
Yeah, and we really hope that by building it into Tempo, it will just be much easier to generate these metrics. You don't have to set this up on the agent anymore. You can just run it on Tempo, and the backend can generate them for you.
Cool. Excited about that. I really want to see it in our operations cluster internally. I think we're only running it in dev right now, but I think especially the automatic exemplar thing will be a great way to be able to see kind of trends in your spans and then jump back to the traces that are having the issues. Very cool.
Yeah, for sure.
Speaking about linking traces to other forms of telemetry data, I think we have some people from Pyroscope here who are interested in sharing some of what they've been working on, which I believe is linking traces and continuous profiling. So I'll give this over to Ryan, and yeah, show us what you got.
Cool. Yeah. What's up, everybody? Yeah, I'm Ryan. There's a couple other people from Pyroscope in here. If you don't know what Pyroscope is, it's, as Joe mentioned, a continuous profiler, open source, and something that we've been working on a lot lately has been, this idea of like being able to link different types of, like telemetry data to profiles. And so I will show you, we kind of have like the beginnings of kind of getting this in a, I guess we kind of have the beginnings of getting this in more of like a production state. But one thing that we're definitely interested to learn more about is sort of how we can design this in a way that would be most useful for, in this case, particularly tracing, how you could get more, I guess, like value out of your traces by being able to see the profiles associated with, specific spans. And so, I don't know, maybe, let me see. As you said, the button always moves. How do I share my screen? Here we go. Your entire screen. Let's choose the right one. And I believe you should see all of yourselves right now. Yeah.
Yep.
All right, cool. So yeah, I guess I won't get too much. I mean, if you aren't familiar with profiling, we do have like a demo page you can kind of see, but just like real quickly for anyone who's not familiar, basically this is a flame graph. It's a visual representation of sort of resource utilization, in this case CPU, where the top is 100%, and then each node below that is a function that this function calls this function, which calls this function. So this is kind of like a pie chart on steroids, sort of like the path of your code and resource utilization. As far as what we did for this kind of like example, so basically we just created kind of similar to Jaeger's hot rod example, if you're familiar with that. We created sort of our own little like rideshare example to kind of represent this. There's multiple endpoints: car, bike, and scooter. Literally, you just order a car, order a bike, order a scooter, and then so that's what this tracing example is sort of showing. There's a load generator that is generating the load just so that you can be able to have something to look at for the traces in the profiles. And so that's kind of the structure of this application. And we can also, after this, right now it's sitting in a branch somewhere. I guess I can paste that in the chat after this example I'm about to show. But basically what we have here is, so we have this running in Grafana. And so if you do like search, you can, as I said, there's these two. There's the load generator app and then the ride sharing app. the ride sharing app is more interesting. So if we search here, you can see a bunch of different traces, and I'll just click on one random one. And again, as I mentioned, it starts off in the load generator, and then from there, it gets into the actual ride sharing app. And so the thing that we did here was we added this like Pyroscope profile ID and Pyroscope profile URL, which for now opens in a separate tab. And so basically what you will see is that in this tab, for this specific span, this yellow span right here, for this specific span, this is the profile for, again, that specific span. So in this case, you can see it's calling this car.orderCar function. That's what it's spending most of its time working on. Yeah, I didn't really get into it. We made the ordering a car go extra slow on purpose, kind of to exemplify some other aspects of this. But basically, yeah, that's what's happening here. And as you can drill down, as of right now, we only show the profile for like the route span here. Eventually, maybe we will, or we'll likely kind of add it for each one individually as well. Yeah, that's kind of the gist of, or kind of like at a very high level, the idea here. What we kind of hope that we could do eventually is we do have a Grafana plugin as well, and it would be cool to be able to kind of come into this Explore tab, similar to as you were just showing, or somebody was just showing, where you were able to kind of link the, a bunch of things to the traces. It would be cool to have that here. We have a similar query language to PromQL, or it's almost identical. And so if we actually, copy and paste that in here, you can see the, obviously this is not a flame graph. This is a JSON that would otherwise be a flame graph if that was a supported visualization type here. If I do go into the actual, let me see. Yeah, I guess here we go. So yeah, so basically if I did go into here and I were to like paste that exact same query in here and hit apply, then you can kind of see it in the panel over here. Yeah, I guess, I don't know, as you may know, these panels, this is like a custom visualization panel that we made specifically for Pyroscope, whereas the panels that are available to actually like visualize data here are sort of hard-coded to be either graphs, tables, logs, traces, or node graphs, I believe, if I'm looking at the right thing here. And so anyways, that's something that we kind of hope to eventually, potentially lobby Grafana to allow either custom visualizations here or something other than those sort of blessed visualization types, or add profiling to those visualization types there. But yeah, that's kind of from a high level how this all works. We can get into more of like how it's implemented or whatever's interesting to you there. But I would say that from my side, from Pyroscope's side, the thing that we're most interested in from you all, people who are using tracing and using it frequently, is sort of what are the, does this sound interesting? Would this be something that you see an actual like use case for, being able to go from a trace or a span to the profile associated with that, and just kind of in general sort of, whether it's for incident solving or capacity planning, whatever it might be, just improving user experience in general and being able to kind of move throughout your sort of the life cycle of whatever your application is doing. Just honestly interested to get your general thoughts that can help us sort of plan as we design this and build this, that we're building it to be something that's actually useful. And we figure this is a space where you guys are most familiar with tracing, or probably more than most. And so yeah, would love to hear your thoughts.
Cool. I do have a question about the profile that I think will help me understand like how I can use this. So generally with like CPU profiling, right, you are sampling the stack, right, at so many times per second, and then you're building your flame graph out of this. So when you're doing this link between the trace and the CPU profile, is the flame graph somehow scoped down only to the request, or is it the state of the process as a whole at the time of the request?
It is scoped down to the request. Hi, I'm Dimitri, also from Pyroscope. In Go, there's actually a very cool way to basically tell the runtime that this particular function, or I guess this particular Go routine, belongs to this trace or something like that. And that's how we're able to, really scope it down. And so it doesn't include other things like garbage collection or, other background threads in that profile that Ryan showed.
Cool. So I think my instinct here is I think both have a lot of value. Like some people do a lot of just like in-out tracing, right? Just the requests, the HTTP request in, the HTTP request out, and internally inside the process, there's still a lot of questions about what's happening. And I think what you've done here is awesome in that case. Like you don't have to do any specific instrumentation. You don't have to do anything manual. And you can immediately see the state of, the stack. All of the stuff that you didn't instrument is given to you kind of automatically and for free by jumping over. But I also think there's a lot of value to knowing everything that's going on in the process at that time. If you have a long running query and you don't know what's going on, and it just was this weird one off, and you click it and you just see that, oh, the process was spending half its time in garbage collection or something, you can write it off, or you can go make a point to go reduce your, your stat or your heap allocation or something. So I think both would be really cool. Having the option just to see everything that's happening in your process at the time of the request can give you a lot of insight into maybe what else your process is doing that could help you understand why your request was slow. So I do think this is pretty cool. I've been trying to use profiling more as a general tool. And I think this could help me kind of bridge that gap, like get me into Pyroscope more instead of just bringing it up occasionally when I'm having issues, like use it more regularly and, give you more insight into your processes.
Yeah. One thing I would add there too is just that, so like that, is, while that's sort of like the specific profile for that trace. I mean, the other thing that's nice about, continuous profiling is there also is, if we, removed those specific, profile ID from the query parameters there, you would get, a full profile, and you can also, it's also tagged appropriately. In this case, it's tagged by vehicle and region, as I showed in that kind of graph. And so you can kind of zoom out that way as well, and be able to see sort of just like at that time, and also if you're using Kubernetes or something along if you're using Kubernetes, you can see for that pod or for that namespace or whatever, you can slice and dice it how you want. And so we're kind of trying to figure out like what the balance is there between being able to see as high as you can, but then also being able to drill down to like very, very granular as well.
That's cool. Like, I see that as a cool UI improvement, right? Where you could toggle on the rest of the process, toggle off, like or you could just like show as a shadow mode or something, where it'd be really interesting to see them both at the same time, right? I do think that would be really neat for sure.
Mm-hmm. Yeah, and then also being able to like compare sort of like the full. I don't know. Yeah, Demon, you want to talk about what you were talking about earlier with comparing the sort of like full path of the. I don't know. I guess exactly what you call it, like the trace, the full path of the span versus like one that was particularly slow.
Yeah. So this whole idea with attaching profiles to span started by like originally we had only kind of like full view of your application, right? Both garbage collection, all the threads, everything. Some people wanted to, kind of get more detailed information. And so now we have this feature. But now that we're talking about this, another thing people are asking for is kind of be able to compare a particular profile for a particular span to kind of like all the other profiles for that particular span. And so we're starting to think about how we could do that, basically compare it to some sort of a baseline. So it's somewhere in the middle where it's not like your whole application. It's not a particular span, but it's kind of like in between. Hope that makes sense.
Yeah, no. I mean, these are the kind of things that I think would get me into profiling more, instead of just pulling it out when I need it, like once a month, like actually making it like a regular part of my, understanding of the process. Personally, I find myself staring at metrics a lot, because I like that. I like to get a feel for the process and what it's doing. And I think it would be neat if I also had a feel at the profiling level, like just every other day, once a week, just jump in there and just see what it looks like during a normal period of time, and get a intuitive feel for what the state of your process is. And I think these kind of features would bring me in more.
Cool. Well, awesome. Well, yeah. Go ahead.
I had one more question if we've got time. And sorry, I know you can't see me. I'm Ananya. I'm part of the Tempo squad at Grafana. First off, really cool product. I had one question around sampling, actually. So it seems like you would almost be storing profiles for every request, and that's kind of like similar to what we deal with tracing. And also, it's like Pyroscope seems to be a pull model from what I've read. So is it like how do these profiles for every request actually, how do they get picked up? It's almost like we were dealing with this with exemplars. When we add exemplars to the metric, we ship those traces, but it's not necessary that the exemplar will be scraped by Prometheus and land in the UI. So do you actually sample 100%, or do you have like these rules in Pyroscope as well?
We do use sampling profilers, so they're sampling in terms of like how many stack traces do we look at each second. But when it comes to actually storing them, we store every single one right now, like every single profile for every single profile ID.
So this is like it's almost every request creates a profile, and that would be stored together with the trace ID. Okay, cool. That's a lot, but yeah, it's valuable.
It is a lot. So for we build a pretty good kind of storage engine compression algorithm to be able to kind of scale vertically. And like even if right now you install just one Pyroscope server and scale vertically, you'll be able to get pretty far. For the future, we are planning, we're planning some sort of more scalable solution so that you could do you could do horizontal scaling, basically.
Very cool. No, we use Pyroscope already. One of our, I think the highest volume cluster uses Pyroscope.
Nice.
In Tempo. Yeah. Cool. Thanks.
Sure. Well, yeah, we'll definitely try to add a Tempo example as well to the. We're still, like I said, we haven't really been promoting it yet. We want to do some some UI stuff around this and some cleaning up the way that we do it in the backend as well. But yeah, I mean, once we kind of make more progress there, yeah, we'd love to kind of share it with this community and have you all try it out and get some more feedback on it. But appreciate you giving us a little time to talk about it today.
Absolutely. Thank you all. It was awesome. If anybody has any questions about Pyroscope for that team, or just about Tempo or continuous profiling or distributed tracing or any of these fields, that would be a good time to jump in. You can chuck it in chat or you can unmute. Otherwise, I'd like to thank all of our friends from Pyroscope for showing up, of course, as well as everyone else for coming in and participating in the community call. If there are no questions, it is only 5 minutes left. We can head on our ways. Generated metrics. Okay. Why don't you, Gabe, you can ask or have.
Sorry, just wanted to make sure I don't want to step over everybody. Do you know what's the performance impact of the generated metrics right now? When approximative?
Yeah, so by adding the generator, the distributor has to do a little bit of extra work since it's sending requests both to the ingesters and the metrics generator. So there will be a bit of extra CPU, but it's not really significant since we don't have to do any extra processing that we don't have to do for the ingesters. And the generator itself, like memory usage and CPU seems fine, like seems pretty low right now, but we haven't been able to test it at like a good scale yet. So we've tested in like a small dev cluster. It seems to be using like half the memory of the ingester right now. So that seems all right, but we still have to test it at scale.
It's a separate component, right? Is the
Yeah.
okay, cool. I had forgotten that. Okay, nice. Is that what also generates the service graph that you were showing?
Yeah. So it generates metrics, and these metrics are used by Grafana to show the service graphs.
Nice, that's awesome. Thank you.
Okay, cool. Yeah, something we noticed with the resource usage of the generator is that memory usage is correlated to the amount of active series you're generating, and not necessarily to the amount of spans you're ingesting. So this is different from the ingester. If you have like if you're ingesting a lot of traces with a low cardinality, your memory usage will be lower than if you ingest like just a small amount of traces with a huge cardinality. So it's a bit tricky to estimate at this point.
Good to know. Thank you.
All right. Well, thank you all. Good community call. Congratulations, us, everyone. All right. Take care, everybody, and we will catch you in a month or so.
All right. Nice meeting everyone. Have a good one.
Bye everybody.
Thanks again.
Bye.